Alright guys, this is the last section. It is 7.6 part 3. And I'm going to actually go back to the first page where we left off. This page here, it says that we have to do this example because I did the previous example on part 2. Alright, so we're going to do this one right here where it says y equals cosine x minus pi over 2. Now, we don't have an omega. The amplitude's 1 like normal, but we do have this situation, which is x minus pi over 2. Okay, that means we're going to have to take the graph of cosine, and we're going to shift it to the right pi over 2 units. So let's see what happens when we do that. Let's graph it out. So once again, when you're doing your homework, I expect you to graph the parent function. So the parent function, remember we're graphing y equals cosine x. Okay, so the 4 key points again are pi over 2, pi, 3 pi over 2, and 2 pi. Alright, cosine goes up to 1 and down to negative 1. So the graph of cosine, once again, looks like this. And you have to have that memorized by heart. Okay, so the next step is we're going to take this function and we are going to shift it to the right pi over 2 units. Okay, so what I'm going to do for you is I'm going to draw the parent function just to show you where it is, and then we're going to move those key functions, or the key, not the key values, we're going to move the values pi over 2 units to the right. Okay, so if I have to move everything to the right, I definitely want pi over 2 units over past 2 pi. And also, the amplitude doesn't get affected, so we don't have to worry about that. Okay, so the original function, cosine 2x, which I already have drawn for you, looks like that. Now, in red, we're going to shift everything. So I'm going to take 0, which is right here, I'm going to shift it pi over 2 units to the right. I'm going to take where pi over 2, cosine equals 0, I'm going to shift that to pi. And then at pi, the value is negative 1, I'm going to shift that over to 3 pi over 2. So all I'm doing is moving my points 90 degrees. At 3 pi over 2, my value is 0, so I'm going to shift that to 2 pi. And then finally, at 2 pi, my value was 1, so I'm going to shift that to pi over 2 units away from 2 pi. So now, what does the graph look like? It looks like this. So all I've done is I've taken the original and I've moved it pi over 2 units to the right. Now what is that graph? In red, what graph is this? Yes, it is y equals cosine of x minus pi over 2, but it also is y equals sine x. So both sine and cosine are known as what's called sinusoidal waves. Okay, so we got that one done. And by the way, on the next page of your notes, it shows this. So once again, we take cosine and we move it pi over 2 units to the right, and we get the sine graph, which I just have put in red. Okay, so for sine and cosine are sinusoidal functions. If you should have a negative sign in front of x, so if you have a negative inside, x, where omega is, you have to use the even odd properties first to ensure that omega is always positive. So an example of this would be if I have y equals sine of negative 2x, you have to apply the even odd properties first. sign is odd, so the negative comes out. And then you would graph this, negative sine of 2x. So that's just an example. You can't have that negative right in front of the 2x. Okay, so omega always has to be positive. The amplitude and period of y equals a sine of omega x and y equals a cosine of omega x are given by the amplitude is always positive, guys, and the period, if it doesn't end at 2 pi, you can find it by doing 2 pi over omega. Alright, we've used that function once. We'll use it again here. Alright, so it's asking me to graph this next one. This next one has a lot of steps, so we're going to take it step by step. First of all, we have an amplitude. The amplitude is 4. We also have a negative sign, so I know I'm going to have to flip this entire thing over the x-axis. Okay, we also have omega. Omega is pi. See how it says pi x? And we also have a shift here. We're going to shift the entire graph down 2 units. Okay, so geez, what do I do first here? Most of the time, the first step that I'm going to take care of is omega. And we'll take care of the amplitude. So omega, remember, we can find that period by taking t equals 2 pi over omega. So 2 pi over omega is pi, t equals 2. Alright, that's your ending point. So instead of ending at 2 pi, you're going to end at 2. And to find your 4 key points to replace the original parent function, we're going to have to take that ending point and dividing that by 4. And when we do that, we get 2 over 4, which equals 1/2. 1/2 is your first point. Okay? So 1/2, to find the second point, we're going to take 2 times 1/2, which equals 1. The third point, you just multiply by 3 by that first point, so 3 times 1/2, that's 1.5. And then your fourth point, just to check, make sure we get back to the ending point, is 4 times 1/2. So 4 divided by 2 is 2. So we're good, because the ending point equals my fourth point. So once again, what are my first points? 1/2. Then I'm going to use 1, 1.5, and then finally 2. Okay, so those are going to replace my parent function key values. Alright, the amplitude, once again, is 4. So let's see this in action, and then I will deal with the flip and the shifting the entire graph down 2 units. Okay, guys, parent function. So you always have to graph those when you're doing your homework. I know I've said this over and over again, but it's helpful. Alright, so the parent graph is y equals, and let me just check this again. Wrong page. Okay, guys, just my notes got out of order here. Here it is. Y equals cosine x. Okay, so the 4 key values are pi over 2, pi, 3 pi over 2, and 2 pi. Alright, values go from 1 to -1. Alright, parent function of cosine looks like that. Okay, now I'm going to graph. I'm going to take care of that amplitude, which the amplitude we found was 4, and then pi x. Okay, so please keep in mind those 4 key values we just found because we're going to be using them. So let's go ahead and line everything up. Okay, so 4 key values are no longer pi over 2, pi, 3 pi over 2, and 2 pi. They are now 1/2, 1, 1.5, and then 2. Okay? Alright, and instead of going from 1 to 1, I'm now going up to 4 and down to -4. Okay, alright, so let's graph this. So basically we're taking the same graph that we just drew and we're just making it taller. So it looks like this. Okay, alright, so now we have y equals 4 cosine of pi x. Okay, so we only have really 2 more things to do. 1, we got to flip it over, and then 2, we got to take this graph and shift it down 2 units. Okay, so on the same page, what I'm going to do, whoa, that's really crazy. Okay, let me get the blue pen out again. Okay, so I'm going to draw my graph. Once again, all I'm doing is flipping it over the x-axis. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. And once again, my key values, I'm going to have to draw them out again, no problems. Okay, so I'm going to flip it over. So remember, at 0, the value was 4, so now it's -4. The value at 1/2 was 0, it's still 0. Okay, the value at 1 was -4, so now it's +4. The value at 1.5 was 0, so that's fine. And the value at 2 was +4, so now it's -4. So all I've done is flip this over the x-axis. So what's this graph? This graph is y equals -4 cosine of pi x. Alright, we have one more step. What we're going to take is we're going to take this graph that we just drew and then drop it down 2 units. Okay. Alright, so quickly, just because I switched the screen, you don't have to do this. I'm just regraphing what we just had. So bear with me. The graph we just had was where we reciprocated it. So it looked like this. Okay, so that's the graph. This is y equals -4 cosine of pi x. Okay, now this last graph here, I'm going to take the whole graph I just drew and I'm going to drop it 2 units down. So instead of ending at -4, if I drop that down 2 units, I get -6. Instead of going up to 4, I drop that down 2 units and I'm going to go to 2. So basically what you're going to do is you're going to take all those points we just drew and we're going to subtract 2 from the result. Okay, so once again, we're going to go -1, -2, -3, -4, -5, and -6. We're going to drop down to that, and we're going to actually go up to 2. Okay, because 4 minus 2 is 2. Okay, so let me go ahead and, keep these lined up. I have 1/2 in the same spot, 1 in the same spot, 1.5 in the same spot, and 2. Okay, so everything's lined up, so all I'm going to do is take my values and move them down 1 unit. Or 2 units, excuse me. So at 0, when y equals 0, the output is -4. So if I drop it down 2 units, I just subtract 2, so it's -6. When you plugged in 1/2, you got 0, so now that's -2. And when you had 1, you had +4, so drop that down 2 units and you get +2. At 1.5, it was 0, so you drop it down 2 units and you get -2. And then finally, at 2, it's -4, you drop it down and you get -6. Okay, so the graph looks like this. And I do want to point out that some people like to put in the new 0 line. So if you drop 2 units, this is where 0 was on the original graph. So you're taking the whole graph and just moving it down 2 units. But the red graph is what I want, okay? Because this is my answer. And you need to show, you know, where its height is and where its max and min are. Okay? So that is the function, and we're done drawing that. So we're almost done with this section. Okay, so this last part requires you to know those parent functions really well. So really quick, here's a parent function for sine. Okay, so here's pi over 2, pi, 3 pi over 2, 2 pi, and it goes from 1 to negative 1. Okay, and it's good to know the parent function of cosine. So 1 to negative 1, same values, pi over 2, pi, 3 pi over 2, 2 pi, okay? So I know I keep on drawing these over and over again, but it's good to do that yourself so that way you know what the parent functions are. Okay, once I have the parent functions, I can figure this stuff out. One, if I look at this graph, you know, as compared to the parent functions, I see that the amplitude is 2 to negative 2, not 1 to 1. So I can say that I know that A equals 2. The amplitude equals 2. Alright, I also see that it doesn't look like cosine, it doesn't quite look like sine. But if I would flip this graph over, I would have the sine wave. So I know that it's probably sine x. Now you could use cosine, but you'd have to shift it pi over 2 units to the right. So I'm going to go ahead and erase that. Okay, the other thing I got to deal with is the period. The period does not end at 2 pi like the parent function. It ends at 4. Alright, so if I know that the period equals 4, I got to find omega. So if I use this formula, I can figure it out. So 4 equals 2 pi over omega. Multiplying both sides by omega, I get omega equals 2 pi over 4, which equals pi over 2. Okay, so I have omega now. So I can write up my function. My function is y equals, put the amplitude first, 2, function, sine x. Remember we have an omega, so omega is pi over 2 times x, and we flipped it, so we need the negative out front. So how did I figure that out? The generic form is y equals a sine omega x. So I need to find those values. So once again, I looked at the graph to find a. I had to use the formula to find omega. And then I had to look at the function and compare it to my parent functions to figure out what function it is. Okay, I hope that helps you with the homework. Don't forget to take the quiz on this section. And that is it for 7.6. You're done.